Chapter 1, Section 10, Digging Deeper. What is an earthquake? Earthquakes. You used models to find out what happens with the release of energy from an earthquake. Recall that an earthquake is a sudden motion or shaking of Earth as rocks break along an extensive surface within Earth. The rock masses on either side of the fault plane slip past one another. This slippage can be for distances as much as 10 meters during the brief earthquake. The rocks break because of slowly built up bending. The sudden release of energy as rock ruptures causes intense vibrations. These vibrations are called seismic waves or earthquake waves. Seismologists explain the occurrence of earthquakes in the following way. A fault is a surface between two large blocks or regions of rock along which there has been rupture and movement in the past. Faults are very common in the rocks of Earth's crust. Large-scale forces within Earth's crust push the fault blocks in opposite directions. The movements of Earth's plates cause most of these forces. You looked at a variety of different types of faults earlier in this chapter. As the forces gradually build up over time, the blocks are bent on either side of the fault, the same as with the styrene foam strip. The region of bending can extend for very long distances away from the fault. All rocks have shear strength. The shear strength of a rock is the force that is needed to break the rock when it is acted upon by forces in two opposite directions. Eventually, the forces overcome the shear strength of the rock. The rock then breaks along the fault plane. The blocks then suddenly slip for some distance against each other to undo the bending, elastic deformation. The stored energy is released. The straightening movement is called elastic rebound. So in Figure 1, this image shows behavior of a fault as plates move. The rocks along a fault do not move continuously, but rather become locked or stick for a period of time before they slip or move. Usually, the rocks in a fault zone have already been ruptured by earlier earthquakes. Why do the rocks not just slip continuously as force is applied? In some places, they do slip continuously. In most places, however, the fault becomes locked. It does not move again for a long time. There are two reasons for this. One reason is that there is a lot of friction along the fault plane. Because the rock surfaces are rough and are pressed together by the great pressure deep in Earth. You can see for yourself how effective this rock friction is. Imagine gluing sandpaper to two wooden blocks and then trying to slide the sandpapered surfaces past one another while you squeeze the blocks together. The blocks would resist movement. The other reason is that new minerals tend to be deposited along the fault by slowly flowing water solutions. This new mineral material acts as a cement to restore some of the shear strength of the rock. Earthquake or seismic waves. When an earthquake occurs by rupture along a fault, the elastic energy of bending is released. The energy spreads out as seismic waves from the focus. Earthquakes produce several kinds of seismic waves. The different kinds of waves travel through rocks at different speeds. Each kind of wave causes a different kind of motion in the rock as it passes by. The various kinds of waves arrive at some distance point on Earth at different times. When each kind of wave arrives depends on its relative speed and its path through Earth. Compressional waves cause rapid compression and expansion of rock as they pass through the Earth. As the waves pass, the rock material is moved back and forth in the direction of wave motion. Compressional waves are the first to reach a location away from the focus. They are called primary waves or just P waves. Primary waves are similar to sound waves. They can move through solids, liquids, and gases. They move through solid rock at the speed of about 5 kilometers per second, or about 15 times the speed of sound in air. Shear waves arrive at a location after compression waves. That is why they are called secondary waves or just S waves. Shear waves move rock material at right angles to the direction of their motion. S waves can travel only through solids, not through fluids. They move through rock at a speed of about 3 kilometers per second. Surface waves, which travel along Earth's surface, are the last to arrive at a location. They travel slower than S waves. There are two kinds of surface waves. One kind creates an up and down rolling motion of the ground, very much like a wave on a water surface. The other kind of surface wave shakes the ground sideways. Surface waves usually cause the most movement at Earth's surface and therefore are the most damaging. Let me scroll up a little bit. This diagram shows how this diagram shows how different types of waves move through Earth. And here's the types. Primary, let me zoom out a little bit. Okay, A is primary, B is secondary, and C are the surface waves moving through Earth.